problem 1 and the only problem for concrete form design 3. A 12 feet high wall 10-inch thick is to be placed at the rate, so to give it R, CR, 10 feet per hour at the temperature T, 75 degree. Hint, use a table attack from the ACI, American Concrete Institute, SP4, formwork for concrete. Calculate the maximum concrete pressure on the formwork. That you can use your knowledge in concrete form design 1, the previous week lessons, to determine the concrete pressure. Assume that the 3/4 inch plywood is to be used with the face grain parallel to the span. What is the face grain parallel to span? Just go to the previous lesson to see the model of that. At the sit-in with no studs, that is, as you can see in the vertical form like goals, they have sit-in, stuck, wells, and tie. But in this case, no stuck. What is that? You can go back to the concrete form design 2, and with the slide it shows the difference between the go form without stuck and go form with stuck, so you can see what the model look like. In this case, no stucks. If the ties are to be spaced at 24 inch on center, calculate the resultant maximum force on the tie if the wells are continuous over 3 span, the wells. So with that one, let's do the first EA, determine the maximum concrete pressure. In this case, the height is 12 feet for the wall, and the rate of concrete placement is 10 feet per hour. So first, concrete pressure. Then we can go to the concrete form design 1 with the equation that you have, and for the walls, and the rate is 10 feet per hour. So as you can see, it will be for walls 15 feet per hour, so that it in that range. So we can have this equation to determine the P max, the concrete pressure. So let's rewrite that equation. So we have P max equal to coefficient of unit weight of concrete, chemistry coefficient, times 150 plus 43,400 over T plus 2,800 rate of concrete placement over T. And in this one, concrete pressure on formwork, we assume the concrete here same as the previous problem, that have CW equal 1 and CC equal 1, same as problem 1 and 2 in concrete form design 1, if you want to go back to there. So we have that, we have P max equal to 1 times 150 plus 43,400. The temperature 75 degree plus 2,800. The rate of placement 10 feet per hour times 10 divided by 75. Then we have this one is P max equal to 1102 psi, 1102 psi power per square inch. And yes, actually between, we need to make sure that it between minimum 600 CW, which is 600, and WH, which is 150 times H 8 times 12, so that great amount, so between that. Then from that we can determine the H, the height, to get the Pmax, if you recall, that is S apostrophe equal to Pmax over W. And let me assume that same to the previous problem. If they don't give us to here, assume W is 145 pound per cubic foot. So we have 1102 divided by 145. Let's assume that same to concrete form design 1. Then we get that one equal to 7.6 feet. So how does it look like for the distribution? So now, as you can see, the goal is now the goal, and that is 12 feet, and the distribution there and the H apostrophe it mentioned there 7.6 feet. Then the Pmax will be uniform for the remaining of the height, and of course if you subtract 12, subtract that, so it will be 4.4 feet. So that is the distribution, and the Pmax here equal to 1100 out to psi. Power per square feet, not psi. So that one here you need to change. That is the power per square feet, power per square feet. So that is one. Again, this part you can go back to problem 1 and 2 in concrete form design 1 lesson last week. You can get that. And then B, we want to determine the maximum allowable spacing of wells, and in this case no step, based on the maximum concrete pressure. So we have concrete pressure already determined, 1102 pound per square foot. So in this case, as you can see, one of step is we need to select appropriate structure models, select the table. So with that one, let me assume to use, they only give us one table here, and this table apply for the safe spacing in inches of support for plywood sitting continuous over 4 or more support, and that's what we assume. If in the real life, whatever your support is, you have multiple table in the book that call that ACI SP for Formwork for concrete there. So here, assume that the plywood sitting will be continuous over 4 or more support, and be in stress, bending stress is 1930 psi, so that we can use the table in here. So that, and that table, there are two scenarios: the face grain parallel to span and face grain perpendicular to span, as you can see there. So with that one, we have the problem give us the wells, and that you the face grain parallel to the span, face grain parallel to span. So that's what we need to use. So that one we can say from table with concrete pressure Pmax equal to 1102 pound per square foot. So what will we have? Go back to the table, jump up here. So the amount that you receive, that is the concrete pressure 1102, so it's about 1100 pound per square foot, and the plywood thickness in this case is 3/4 inch, then and face parallel to span. So that's why we use this column. And the plywood thickness is this one. So at the end, you choose the safe spacing in inches will be this number 9. So that's what we read the table in there. So with there, we can say that the with the Pmax, so we can have from the table, we can have the maximum spacing of wells equal to 9 inch, and for 3/4 inch of plywood, and that is the face parallel to the support, face grain parallel to support there. So that should be the answer for B. And go to the C. If the tie are to be spaced at 24 inch on center, calculate the resulting maximum force on the ties if the welds are continuous over 3 spans. So with that, we can go to C. We can determine the maximum load per linear foot of wells. So what it should be, we have the spacing in 9 inch for the wells, and the concrete pressure equal to 1102 pound per square foot. So we can say the load per linear foot for the wells is equal to spacing times the concrete pressure. So you can see that one is equal to 9 inch, and we do the conversion over 12, so we get 827 pound per linear foot. So this we use this and did that a lot in concrete form design 1, when we determine in problem 3, and concrete form design 3. So with that, we can see with the 24 inch on center for the tie, then we can be able to determine the resistance maximum force. Maximum force on the tile. And it equal to the load per linear foot of wells times the on center. So in here you can say that is W. So it will be W times W small, the distributed load, times the tie spacing, and that equal to 827 pounds per square foot. Tie spacing given 24 inches divided by 12 inch per foot, so we have 1,654 pounds, and that is the maximum load applied on a tie. So when you select the tie, it need to be have the allowable stress, allowable force have to be greater than 1,654 pounds. And that for problem 1, and the only problem in concrete form design 3.